So one of the things we want to pay attention to as we go to start this is if we're referencing a drawing, and if we're referencing, if we're doing a lot of drawing references, we're going to start seeing some examples of where we need to be paying real careful attention. So we're going to start by creating a simple version of a 3D object. So I will randomly choose a desk object because that's easy enough to do. So I'm going to use real material for this as well. I'm going to recreate this glass dish. And no worries, Caleb, there's going to be dropped connections and internet issues and all the things. And that's why I'm doing the recordings, just to make life a little bit easier. So for an object like this, what I'm going to do is I'm going to look at where the symmetry is. And because it's a bowl-like vessel, what do you guys think? Let me know in the chat. What's the best way to leverage the symmetry of this kind of an object? So which plane should we pick, and why? What kind of technique should we be thinking about already? Let me know in the chat. Okay, getting some answers in. Good. Good. I'm already seeing some right thinking about this. So the simplest way to do this is starting from a revolve. And in this case, since it's bowl-like, I'm going to start with a rectangle. So here's the first part of our bowl. We're going to do a few more kind of slightly more advanced things today in the feature or in the sketch window before we go to do features and operations. So you want to make sure that you're following along for all of it. For smart dimensions, we're going to set this to be, this is why I said calipers are going to come in handy for a whole bunch of things. So you can find a fairly inexpensive set. You'll want to for sure pick up calipers in some variety. There are some available on campus in some of the engineering rooms. Weirdly, not all of them, but is what it is. So right below the rim, or at least as far as I can measure there, we're right at, I'm going to call about 95 millimeters. So somebody who's really sharp at math, tell me what approximately half of that value is. Because we need to know what half of the drawing is. Good. This is how I make sure you guys are staying awake, or at least one or two of you are. So one or two of you will learn something. The rest of you, well, jury's out. So total height, we want to measure. And this guy is 50 millimeters. So today is a couple simple examples of walking through some simple operations. I'm going to add another rectangle to represent the rim that this particular glass vessel has. And that has a overall width of about 8 millimeters at a height of about 7. So 8 by 7 millimeters. Eight by 7. So I wasn't too far off in my aspect ratio there. In order to continue doing the sketch development, what we're going to do is we're going to try and capture as many of these individual features as possible. And we want to create an enclosed volume as if we were to cut or bisect the object itself. So we want to be really careful about how we do this. There's a couple ways that we can do it. One of the other tools that you saw used that I guess we can go ahead and use for this purpose, but it'll allow me to show you like 12 things at once, which always make for really good videos. You guys can pause and go back and watch the same section like 36 times. It'll make for great fun. So we want to offset the entire sketch, but we want to be able to do that in a reverse capacity. And we want to account for the approximate thickness of this. So anyone ever had to measure the outer diameter versus inner diameter to figure out the wall thickness of a part? We have an idea about the outer diameter, but we need to know something about the inner diameter to get an approximate value for the thickness. And this gives us, right at that edge, right at about 90 millimeters. So those of you guessing that there should be about a 5 millimeter or so wall on most glass vessels, that would be a reasonable assumption. So here we have a 5 millimeter reference inside the sketch. So I'm going to go ahead and say okay to that. Now we're going to delete the parts that we don't need. And that's going to include this and this. We're going to add in a couple line segments. So we want to be careful to follow this reference line again and make sure that we hit a coincident point so that we get both of those associations, so that we get parallel. So we have a horizontal line and we have a coincident point there. That's going to be important. So I will do close to that, but not quite here, to leave a sketch opening intentionally, even though it doesn't look like it. And we'll see what kind of errors that causes. This will bring up several things that we want to use as a reference. I'm going to add 2 center lines just for the sake of reference. So we need one that allows for revolving. We need another that's going to kind of help bisect this and see if I can get away with it. Yes, I can. Good. All right. So we're going to get away with a couple things here, and then you'll see very quickly what kind of problem this creates. First, we're not going to address this yet. We're going to come back to this, but in a lot of instances, the vessels of this type are often not set up with sharp edges, right? So we want to be able to control some of that curve and add curvature. We could go ahead and revolve this. You'll see in a minute, we're going to have some difficulty revolving because of what I've set up here. That's going to come into play in a number of your sketches. So it's something that I want you guys to get into the habit of looking out for. But there's going to be a number of things that we can do, one of which is this sketch fillet. So this turns out to be both a sketch fillet and sketch chamfer. We're going to use those as well, because we're going to try and cover as many different techniques as we reasonably can. So the sketch fillet, you're going to pick which entities to fillet and then how big that needs to be. So I'm going to leave it at 10 for now, just so that you can see what that looks like. You can click on a point or you can click 2 lines. What you're going to find is it's easiest if you click the single points, because it will understand what it is that you're trying to do there. There's some other tweaks and parameters that you can use to try and make some adjustments to these, but for the most part, what this is doing is giving you kind of a gradual radius to this part. And so here you have 2 of them. So when we do this, we end up with a radius in our part. So we could have done this with an arc, but in order to do that, we would have to guess at where the center point would be, set up the arc, and then do some smart dimensioning. And so it's about 6 or 8 steps to do it manually versus coming in, picking the point where you have 2 straight lines intersecting, and then making these parallel. So you'll note that even though they're parallel, the absolute thickness of those two is not exactly consistent, which is actually very much like a real life casting from an object. Why is that? Can you guys figure out why it is that the distance here isn't even between them? What do you guys think? Let's see if anybody knows why they're different. Before I do an actual measurement, let's see what you guys think. So, David, that's the right question to start with. Sometimes you have to pick the tool itself. So, yep, same radius. It's interesting, right? So the same radius. So why do they look so different? Same arc length, given that they're the same radius and the same distance apart. It's interesting, right? So I'm going to go ahead and delete these because I don't need them. But it's interesting. Sometimes you'll have to use the escape tool cleverly. So that radius should be the same. And based on all of our measurements, it should be the same. And if we zoom in, we can see that this actually is a lot more consistent. So if those actually are the same arc and they're the same spacing, how come it looks so different? It's weird, right? This is just an artifact of how some of the things display. This is closer here. This distance, part of what you're seeing, is this distance is a thickness of 5. We're just doing this for the sake of notation. The distance between these two is 7. And then this distance between here is 5. So even though those points are the same distance apart because of some of the mechanics involved, the arc length of the inside arc is actually going to be a little bit different. And it should tell us. So we have 32.5 degrees. I'm going to take a snip of this real quick, just so that you guys can see what the difference is. So that's one. I'm going to leave it right next to it so that we can take a look at the other. So let's take a look what the actual difference is. So different starting point different ending point. The difference is they're both 90 degree. They're both using the same radius. But the difference is we have these are our points in space. And then we have some information about the arc length. The arc length for this outer one has to be longer at 37.5 than 32.5. So this is why things like, for instance, your car has a differential, meaning the wheels on the inside of a turn and on the outside of a turn have to move at different directions or different speeds. And in certain instantaneous instances, perhaps even, in fact, different directions, depending on the type of turn and how severe it is. So this is what the difference is. So the same points have two different arc lengths in order to fillet the sketch. This is just the only way to really see that quantitatively, because even using smart dimensions, you're not always going to see this. So we don't need all of these dimensions going forward. I just wanted to do a quick demonstration for you here because of how this is going to work out. So that's a driven dimension. Yes, but I don't need it anymore. All right. So I'm gonna remove that manually. Sometimes you can use the delete key. Sometimes you can't use the delete key. Why? Because don't try and understand everything in life or you'll go crazy. It's a bunch of passages in Ecclesiastes that'll back that up. All right. So this we have as a set length. And what we don't have right now, because of the way I've set this up, is an enclosed volume because it's not shaded in, or an enclosed area rather. So let's go to look at what happens if we were to do our operation. So if we thought we were done, we want to do this operation and we want to do 360 degrees and we wanted to do it around here. Remember what I said about that thin feature? Really, really, really important. You want to deselect the thin feature. Now, because it's able to interpret some things correctly here, it's able to probably create our object. Now, that doesn't necessarily, just because it can do the operation, doesn't mean it's necessarily correct. And I didn't finish some of the sketch filleting on these other two corners because they're going to be a different radius. So we'll go back and make a base change. I just wanted to show you where the thin feature actually comes up. So we're going to undo that operation, go back to our sketch. Again, get in the habit of resetting your view so that your orientation relative to the part is correct. Another cool trick on sketches, you need a scroll wheel to be able to do it really effectively, but you can hold the control key and the scroll wheel and move your frame of reference around. So you'll see me doing a bunch of stuff like that. If you guys are confused on, wait, how did he do that? Ask questions, because otherwise I don't know that you're missing information. Now this doesn't actually become really an enclosed volume exactly. So this is what we're trying to do is turn this into an enclosed volume. The length of this line changed. So if I go back and I undo a couple other things here, let's step back into the before time. Here we go. So this line, because it's not coincident here, this line doesn't have a reference point that's coincident with the end of this line. And what that does is, if I redo that next stage, this fillet can change. The length of this line changed when I was doing some of the dimensioning on the other parts. So we're going to delete this dimension because we don't need it right now. I suppose it's useful for getting toward full definition. So we'll leave that as our 5 millimeters. I'm going to come in and make some changes there, but one of the things that we can check for is whether or not that is a watertight volume. So this, we actually can use the smart dimension to set to a thickness of 0 to make them coincident. So now we have coincident points, and that association will remain. So we hit escape. So if you guys leave a dimension of 0 on a finished part or something, then I'll know where that came from. And so here we have this kind of coincident point. We can try and zoom in and double check that that looks like they are indeed connected. And that's important. Now, part of the reason why we want to pay attention to that is this is still not behaving as enclosed. So what I'm going to do is I'm going to say, that's not right. I'm going to go ahead and delete it and the reference. And now this line, I'm going to reconnect. I'm going to delete that one actually. And I'm going to manually connect. So now you can see we have a point in space. I wanted you guys to see this. Because of the operation that we were doing with cutting and removing things, you can end up with leftovers that will be confusing. So that point was on this line. Their new features include these yellow boxes to kind of show how things are grouped or call your attention to something that maybe is not obvious just by looking. So back in the olden days, when we were still doing drawing with, pencil and paper, we didn't have things like this, but you guys have some pretty nice features to work with. So this turns out to be helpful because we say, oh, okay, I actually don't need that particular point. This one, maybe that is a reference. Okay, that's being used as a reference for an endpoint for something else. So I'm going to go ahead and leave that for now. Some of the warning messages have gotten to be a little more useful as well. So note that point is still there, but now I've forced a connection between those 2 points. And now I actually have an enclosed sketch, an enclosed area. So now what I can do is I can make sure that we've got what we need. Let me go back to Smart Dimension. I want to set a couple more of those thickness values and try and get the definition to be a little bit more complete. 32.5 is about right. Then our range here, to get the last sketch features that I want, I'm going to go back in and do the sketch fillet again. So I'm going to do a 1 millimeter fillet here, there, and there. So now we've got this, and another kind of good practice to be able to set things up is everything else here is fully defined already. What we're trying to do is we're trying to now get a little bit more definition for some of our radii, for instance. So we want 10 mil between our radii so that it knows something about the overall thickness or width of this part. 5 for here. Yeah, that one's going to be redundant on account of how far away these are. So these two, I think, actually they don't need information relative to each other. They may just need height information. Yeah, relative to the other curves, because of some of the other definition that's taken away. So You want to get in the habit of kind of playing around with it and thinking in terms of what else that's anchored to the origin can I reference, or should I just reference the origin itself to get the XY coordinate details that this object needs? So now we have our fully defined sketch, and we can step out of that sketch and then do our revolve operation. So because I have that one individual line set up, it's now trying to figure out how do I revolve this around that line, and it doesn't really understand how to do that very well. So this is why I said you want to pay attention and always deselect that thin feature if it's enabled by default on a part. This is going to do that same thing where it creates an internal zero thickness geometry. And so likely this triggers an error. Yeah, because of that self-intersecting non-definitional element. In order to get that kind of revolve to work, what you instead need is you need to revolve it here where you don't have an intersecting line. So obviously this is not quite the vessel that we're going for, but just to demonstrate the point that you can get a lot of complicated geometries for a part like this, a lot of features for not a lot of work if you spend your time on the base sketch instead of some of the other details. So just something to tuck away for later when you go to do the CSWA. Hint. Sorry, something stuck in my throat there. All right, so we're going to change which reference line we're using. And now we have an entirely different type of revolve. Okay, so depending on what steps you're doing at the same time, you may have to physically select that region. So if you're starting out, so if I were to just delete that and say yes. So if I were starting, I'm not coming from inside the sketch. There's a big difference between if you're in the sketch, you're editing. So if I go to edit the sketch and then I select the feature, not the extrude, but the revolve. So if I go to hit the revolve, it's going to assume that you're working in this sketch. It'll make some different decisions than if I step out of the sketch and I go to do a feature. Now, especially if you started with this yellow message, you want to get in the habit, again, expand the part tree and pick exactly what you want to operate on. Now we go in, deselect the thin feature because I have yet to see where the thin feature is useful. Maybe that means I don't know as much as I think I mean, but probably not. I've done an awful lot of stuff and things and made an awful lot of parts. And I've even redesigned the entire print head mechanisms for some of the 3D printers I've got and things like that. So yeah, I'm reasonably capable in the software. All right, so we get our blind revolution and we have our vessel. We just need to change the material to make it look and feel legitimate. We're also going to cover a couple things quickly about the mass properties and what some of that means. So under not steel, but under other non-metals, they have porcelain, and then they have I think it's under their ceramics. I thought they had, yeah, there it is. So they do have a glass material that you can apply, and then you can check to see whether or not your part has some bearing on real life by clicking over to the Evaluate tab. This is another one you'll need to know for later. You can look at mass properties. So 285 grams. those of you that have taken any kind of like the Gen Chem 1 and 2, is 285 grams a reasonable weight for about a 4-inch glass vessel that's about 5 millimeters thick? If you think that's a reasonable weight, then that means that we're on the right track. It'll also show you information about center of mass and some other things. So this is one of the other ways that we can check and make sure that our dimensions and our part that we're making actually make some physical sense. Because if that weighed 152 kilograms, probably we forgot to check whether we were in IPS or MMGS or some other system. At that rate, you might have been in MKS or something. So who knows? But you want to pay attention to switching those over each and every time you go to do a new sketch. All right, so there's an example. Now I wanted to do kind of a fun and interesting one because that covers some of the mechanics of this. Later on, we'll add in some text and do some other features, but we're going to use the ellipse tool as well as the circle and a couple others here for the next part. So I'm going to provide you a drawing and then see what you guys can do. So I'm going to give you a few minutes to work on it when I bring it up here. I'll start another new part. So I want to give you a chance to take a look at this and see. So this, so under this tab. So I'm sure I'll end up copyright flagged and banned from YouTube for violating community guidelines or something like that. So we'll see how long this lasts. This is a very, very grainy image. It's worse for me because it's on a big screen here, but it'll give you some kind of a scale reference for the ears, because if you're going to draw the symbol of the ownership of all things in America, then you're going to need some ellipses, not true circles, because turns out that the twin mice owned by the company that owns all the things is in fact two ellipses. So the scale references, each of these sort of major sections is for our purposes. We could call that about 1 inch. And so this one we can actually do in IPS, or we can manually type in dimensions in inches. You just probably want to scale it up, or you could say this is, maybe you could say each of these is 10 millimeters or something like that. So that might give you enough to work with. But since this has got other dimensions in inches, for those of you that can't read invisible numbers, this would be on the order, since this is about the halfway mark, this would be about 1, 2, 3, 4, 5 inch as your base circle. You could also do something like 500 millimeters or something. This would give you, I guess maybe if you're doing it to scale for something like a t-shirt, it might be only about 50 millimeters. But this will give you an ellipse size of about 2.45, so almost about 2.5 by 2.8 inches. So about 2.5 by 2.8 will give you the right size. So I'm going to give you guys a few minutes to see if you can start recreating this shape and turn it into a 3D shape based on the information that you're provided. So we'll go ahead and pause the recording here and give you guys a little bit to work with. So I'll pick this back up here. I'm going to back this up just a little bit to show a couple of those steps again in quick succession. So we go back to the start. Can't really go too fast. All right. So we start with our base circle. We give it an initial size of 5 inches. Then we add our first circle, except the circle really doesn't work, so we get rid of that. We add our ellipse up here. We add our second ellipse. We start giving some dimensions. So both radii get defined. We get everything sized. Now we start pulling our reference. So again, just to show so that's in the record here, how to properly with accurate detail violate all of Disney's copyrights. I'll go back to green for our simple lines. So we need to pay attention in this case for the ellipse. We need to pay attention where these two intersect, because that gives us our point we're interested in. I'll change color so we can see where we measure. So the center line for this guy, if you're trying to figure out on a drawing where it is, you manually need to draw a line. It's good practice. Just to do that, I guess I'll do, let me do that in green as well. So green's how we're finding our center lines. Okay, and here. So you'll start to get a little better trained and have your eye be able to more quickly find the center of an object, but just to demonstrate again how it's measured. So we're going to start from the center point, and we're going to measure out to just below where this intersection point is, and then down. And that is how we find our measurement. So 1 unit, 2.5. So since I'm calling these an inch, 2.5 units, and then 1, 2.25. So 2.25 units up. And that's how we spec our drawing. We have to clear all these. Stop the annotation, then we can jump back. So we set our horizontal distance, set our vertical distance, give it a value, do the same thing for the second ear, and then we come in, trim out the parts we don't need, and immediately hit our copyright violation. And now we're trying to get to full definition. Okay, so after a quick little recap there, what we're doing is we've already got the arc defined. We've already got the center point defined. So in the chat, let me know, what do you guys think we need to do to get the rest of the definition for this sketch? How do we get it to change from blue to black? What information is missing? Think first about what information is present, because we've already specified the width and the length of those ellipses, the 2 radii. What else do we need? How about this information? Where the arc starts. See that? So if we said, actually, that needs to start, yep, right about there. What about this one? The height. Could we also do that by doing this? Yes. In this case, so what if we tell this how far away it is. Now it becomes overdefined, right? So we only need one additional piece of information, in this case, about where the arc starts and stops. And that information is what will set our value. So before that, while one of the ears is still not fully defined, we could have a different orientation of the ear, right? This is why it's important to understand what information is missing from whatever your sketch definition is, because clearly that's not correct, right? But we want to be able to make this all correct. So I'm going to go undo all of those extra rotations there. So if we start from here, because these two should be roughly parallel. Now we go back in, add our smart dimension for either the horizontal or the vertical distance. And now we have our fully defined copyright violation with accurate dimensions. All right, so now you can have all sorts of fun playing around with trying to add various Star Wars features. What about some of the other features, like, say, bow? How do we go about making that? What base geometry would we add to this sketch to include a bow? I'm seeing a very quiet chat. Think about what makes up a bow. Let's draw one real quick. Really simple example. That's kind of a bow. We could do another kind, or we could add some features, right? You could do some kind of fillet. You could do a sketch fillet. The trick is the sketch fillet is going to be looking to do it's going to be confused when you go to do something like a sketch fillet. You'll have to do it one at a time. So you could get away with 10 millimeters, probably. But then what that does is that trims your two other lines. So you have to go back and recreate them. Go here, go here. We're just talking about a couple different techniques. And you could fillet this side too. Kind of does a bow, sort of. And then maybe you'd have to add some additional features there. So a fillet can work. Maybe not perfect, but got to start somewhere. Then once you've got that base circle, now what's the danger is we've created some coincident points but we haven't fixed yet with the smart dimensions what our geometry looks like. So we can get all kinds of strange results by changing our dimensions, right? So we want to be really careful about how we go about doing that. So we can start with something like that. And we could say, okay, I want to move this so what we can do is we could reverse the dimension by making this negative and bringing it up until we get it high enough. Because it needs to be a little bit beyond or on the order of 63 to 65 millimeters. So we're going to start with about 65. So minus 65. Now we want this to be 0 because we want it to be dead center. So now we got to change this 65 to be a little bit farther than that. Let's move it up 10 millimeters. Get us a little closer to where we want to be. There we go. Something like that. So about 75 millimeters. Maybe our bow is a little bit too wide. So I want to set our dimensions. Our exterior dimensions. Maybe that needs to be about, trim about 10 millimeters off to bring them in. Distance between here and the center should be about half of that. So 34. So now those are set. A bunch of you are going to go through this same sort of exercise. So you'll thank me for going through all this in detail. We're changing, using the smart dimensions, all of those key features. So a 1-inch center. And let's do another one that you guys haven't seen yet using the smart dimension. So just checking that everybody else is still in the room. So if you click on a line, it's going to give you a couple different options about how to specify that line. So vertical, diagonal, horizontal, but, and then just different variations of the same thing. But what we want to do is the distance between that line and this line. Now it's not a vertical distance. We want to set the actual angle itself. So you can set the angle on either side of this relationship, or you can set it here. So this one makes perhaps the most sense to us. And maybe that needs to be on the order of 60 degrees. So this and this, you want to be 180. They already are, but you can check it using that. And this need to be 180 degrees. So those two are currently 180 degrees. You want to make sure that those haven't changed. You also need a little bit of information about the length. And there's a couple ways you can do it. I think you can specify from corner to corner that distance. Let's say it's 80. Then the same deal. So this distance, because of how these angles come into play, I wanted you to see some examples of different ways that as you're kind of trying to think your way through how to specify the dimensions or change to meet the dimensions that you're given, you have some flexibility. So we didn't specify this height. And this is where some of the confusion is coming from. So if we set that to be 40 millimeters, we set this to be 40 millimeters, what you end up with is a skewed value. So we want to back up a few steps and lose a couple of those dimensions that we defined, going all the way back to that angle. So starting from here, if we redefine this to be 25.4, so right at 1 inch, then we need to specify using our smart dimension what this value is. So if this is 39 and this is 39, we get a couple more key points. So we've got the distance between these 2 points. And now we want to get the distance between these 2 points. So think for a second about why that's different than specifying. Why is that very different than specifying our angles between these lines? Anyone in the chat think they have an idea why? Why does specifying information about endpoints of those lines work better than trying to specify all of the angles? That'll be your thought-provoking question. So I'll give you guys a few minutes to kind of get caught up on this. I'll pause it here. So on part of this, it'll be helpful kind of to see this as a reference. The angle between these is indeed going to be 180 degrees, but that maybe doesn't mean exactly what you think it means. And you'll encounter this when you go to do some of the parts that we're going to be working on. So if I zoom in here and I start with a center line and I come up here, that center line going through this point. So that, let me make some adjustments to this and show that might line up a little bit better. So I did a little bit more square dimensions. Yeah, so these lines, by scaling the dimensions how I did, these lines maintained their orientation relative to each other. Depending on how that gets defined, these wouldn't necessarily end up being the same. They may still end up being at the same angle, but they wouldn't be along the same line. So where that might be different is if I were to back up a step here and undefine that distance. If instead I set this distance here to be, let's make it 13. That would change the 13 would change the dimensions because these have a collinear relationship. So let me break this in order to show you what that would look like. So that I have to step out of the Smart Dimension tool. And if I delete that collinear relationship by right-clicking, sometimes you'll have to do that in order to make a change. If I did that and now set this to be 14, by breaking that relationship, I can now change the angle of the one relative to the other, so that the types of relationships between those lines is important, and it also factors into whether or not you can get something to full definition. So now you would need to specify, for instance, that the distance here would be the midpoint, or you could specify using on that line the midpoint. If I zoom in a little bit, it'd be easier to see. If I select the midpoint, and because I had this line selected down here, I got an extra feature that's not helping me demonstrate this point. So if I bring this out to this side and set this equal to 0, now I reset this, and now you can see this line and this line are no longer on the same trajectory. So if I were to take this and add a center line, and I were to go through that point, you can see those two lines are not parallel, not even close. So all of that to say, we need to pay attention to what sorts of relations we have. So when we have something like that collinear, we can then specify the one missing dimension and get our sketch to be fully defined. And if we've done a really good job, we can get our sketch to be fully defined and still delete a couple arcs between 2 points because the points are well enough defined. All right, so I'll pause it there and go for any questions on this.
So,
and it's not going to record you. So on something like the key slot type shape, go ahead and start up a new one. We've got another sketch. I'll do this one, top plane, just to make things simple. The way that I think that one roughly is set up is something like this, where we have a couple lines. You can use some reference points, but I'm just going to see if I can get it to let me do a free reference point. There we go. So click along the edge. I want to establish a relationship between them. Doesn't necessarily have to be exactly parallel. Here, then we're going to do an arc. Now, there's a couple ways to approach it. For this particular circumstance, we will use a center point arc, but I'm going to teach you guys a trick on how to set those up. So, especially for something like this, they show you kind of, yeah, they really don't show you an ideal. Yeah, so they kind of show you an animation. So your first point is the center. So whatever your origin is of your circle, for that arc, and then you set the first point on the arc, then you set the second point on the arc. So same kind of thing that we're going to do here, except what we're not going to do is we're not going to try and start at the origin and do it this way, which is probably going to be the instinct of many of you. And here's why. When you do that, you create this kind of misalignment, and you're not going to get concentricity because that arc is not suitable. It's the wrong length. It's not suitable for being able to close this geometry. So you can kind of try and come in here and force it by doing another like little cheater line segment here. But what you're going to find is that ultimately is going to harm you for a whole range of reasons. So instead, what you want to do is this. You want to undo that arc. And for especially some of the more complicated geometries with broad sweeping arcs that are almost flat, but not quite, you want to put the radius somewhere up here where it's still in line with the origin. You can still have some kind of control over it. But then when you do this, instead of trying to force the arc into something, this point is concentric. And this point over here is concentric. Now that means that it's on this same arc. For this instance, that arc doesn't evenly go to be the same height. You can then specify the distance between the origin and that point. Maybe that needs to be a nice even 50. Maybe this is 125. And same deal. This one and the origin needs to be 50. And then maybe you need some additional bit of information like what the radius of that arc actually is. And so maybe that actually needs to be a full 300. And then you can specify some of the other dimensions. So this is probably actually this point that you would want to use for the reference. Depending on what you're doing, this line, I'm going to check the length real quick, 168. And come on. So I'm going to leave that and see what the length of this one is. So not the height. Yeah, so right now these are two different side lengths. That's part of what's causing the confusion. So if that were 168 and that were 168, you're going to get to most of the information there. Then you can specify a distance, for instance, here to here, if you need that, and say, actually, this needs to be, let's say, 35 to start with. And then this one, so maybe this actually both needs to be, what is that? So if we specified both of those at 35, then we can set the overall width of the whole thing. But because we've already defined some of our other geometries, what we can see is that's not actually the information that it's missing. So based on what you know of circles, what geometry or information is it missing? What kind of information? So even deleting the rest of that circle, I've done my homework on the other components for definition. So what do you guys think in the chat? What are we missing? What do we need to tell it in order to get that to be fully defined? What's the geometry that's in question? It's the arc, right? So it has to do with the distance for this arc, but the distance for what part of the arc? Any ideas? How about the origin of the arc? Center of the arc. Because we need to know how far away that origin needs to be for this arc length to be correct. Before that, without specifying that bit of information, we have a constraint, but it's not what you thought. So that's why I want you guys to get in the habit of moving these things around. So we could also equally specify if we were moving it around to check what's not specified, we could set that to be 0. And now we've set, again, some key relationship between the origin of that arc and the origin on the drawing. So that's how to get control over seemingly complicated geometry like that. It's really just a couple arcs and a couple lines. It's just a matter of learning how to specify enough information that it knows where the starting and ending points are. And once all of this is established, there are a couple of these dimensions that aren't strictly necessary for maintaining full definition, but you can leave them there for the purposes of the process. So I'm going to go ahead and pause there and check for some further questions, because there's a ton of material we've covered so far. So some of you might be melting like over microwaved ramen at this point. So another type of geometry that we might need to work with is something like, for this instance, recreating a water bottle or travel mug or something of a similar geometry. So we can again start with some sort of general idea what this will look like. So I might have kind of a tall, narrow aspect ratio. We're going to set it up for revolve. So we're already thinking ahead of that. And we're going to do a center line. We'll do a little more geometry work here. And we'll say the overall height is on the order of 10 inches. The overall exterior width should be about another trick you can do is 3.5 divided by 2 inches. So this one's going to be a little bit taller and narrower. Maybe this is actually closer to 4-inch diameter. Yeah, that's probably more accurate. This one might only be 9-inch height. That's probably a little closer to the right aspect ratio. Then there's going to be some additional geometry we'll need to build in here. So this is kind of our rough exterior geometry. There's a couple kind of interesting things that we can do from here. So I'll show you some examples of both. One is we can use, I guess, one more technique that we haven't used yet. So I'll do the inverse. Yeah, that'll be, I think, an interesting way to do this. We'll do an inverse and do a revolve cut, since we haven't seen a good example of that. So a reverse cut or revolve cut. So we're going to get a little bit more of our geometry set up in here. I'm going to drop the smart dimensions and set up a little bit of, maybe at the base, there's going to be a sketch fillet. 10 millimeters, probably about right. Up at the top, we need to account for whatever the mouth geometry is. And maybe there's some threads involved. So typically that's going to come down a little bit. So a couple millimeters. Then you might have threads. You can use these reference points where the yellow line here is saying that it's parallel to this earlier blue line. And you can use this to get a nice parallel reference point for a couple things that will represent our crude threads here. And then, because it's probably not quite that harsh a stamping, yeah, we're going to do another sketch fillet there. And then we'll do some filleting at the very end. All right, so we have an enclosed volume. And what we want to do is we want to add another region. Let's see, what's the simplest way to do this one? You can add an enclosed region this way. Yeah, that's an interesting way to do it. So I'll do it that way. I'm going to set up a block of material. I'm going to make it about as wide. Yeah, that's probably the easiest way to do this. So I will make a block of material that is as big as our water bottle in area. And I'm going to do, you know what, I'll do a revolve on that one. And then we'll do a revolve cut. So we'll show an example of what this might look like. So we're going to have a whole cylinder. I'm going to have to make one more change to that base sketch, but that's okay. So we have our base cylinder of material. Think of this as maybe like some aluminum bar stock or something like that. We can do a two-step process. I'm going to make one more change. Actually, maybe two more changes to this. I'm going to reset view orientation real quick. Nope, not that way. Here we go. So reset view orientation. And let me see if I can get it to copy. There's a, you know what, I'm going to do a straight edge for this. Make life a little easy. This will give me a pretty good range here. One more. This revolve cut feature turns out to have a lot of utility for a lot of reasons. And I'm just going to do a 3-point arc and cheat a little bit. And do another one down here. There we go. So now I need one more exterior rectangle, and we'll see why. So if we think about this as a block of material, I can now exit the sketch. I'm not worrying about full definition and things right now. So if we think about this as a block of material, it's already done one of the things that I'm going to get to with the revolve cut. So let me edit this feature and tell it which regions to run. This one, and this one, as well as this one. All right. So we'll start with our solid block of material. We'll edit the material to make it a little bit more transparent. Actually, let's do it through the appearance because we haven't spent a lot of time doing that either. You guys need to know how to use all these different features. Yeah. color. Let's do some of the glass options. And let's do something like reflective green. Make it look interesting this time. All right. So this will allow us to kind of see through the material a little better as we do some operations. Now, I need to make some revolve cuts, which we want to think about for using this as a tool. If we were to stick this on a lathe and take away material, what kind of operation would we be doing? We would be doing something with this base sketch. So we're going to do a revolve cut, but it has no idea, since we've done so much sketching, there's no clue what features I'm trying to work with. So it's trying to figure out what kind of cut I want to do. And I have a number of different options. That's why I created several different versions of this. But the first one that I'm going to do is I'm going to use this exterior volume as a portion of my cutting tool. And this is going to be my first operation. So I did a revolve cut. And now I've got most of my features captured. So I've already got a pretty complex geometry. Yes, these are not through threads. We'll get later to how you do true threads on something. I'm just trying to do a representation right now of something sort of like an Nalgene bottle. Guess I'm just in a copyright violation mood today, or trademark violation mood. But you can see this is right now a solid object. So let's take a look at the mass. So right now, this weighs 174 grams. So that's a little bit on the heavy side, not a very portable container, and it doesn't do a very good job at containing at the moment. So let's do that operation one more time, only a little differently. We're going to do our revolve cut again. We're going to go back to this sketch where we stored so much of that information. And it doesn't really know what we want out of this. So I'm going to select the interior region. And then we do our last revolve cut. Make sure that we have our axis of revolution included. And there we go. We have now created the inner wall. And so what I did is I created all of these features that I wanted on the inner wall. And now we have an object that is in fact a container that has threads represented. And we were able to do this with one of our operations. So in each case, we're either adding the material or we're taking it away. And let's take a look at what has changed as far as our mass properties. So now we're back down to that couple 100-gram range. That's a reasonable mass for something made out of a glass, in order to demonstrate what this part is. And it's interesting to see kind of where the center of mass is. In this case, it's roughly at the center of the vessel, which is different from the origin, but you would expect it to be more or less roughly at the center. So this is how we can create some interesting features and geometries by using the inverse of operations. So we've looked at extrude, we've looked at extrude cut, we've looked at revolve, we've looked at revolve cut. We're going to get more into sweeps and bosses and maybe a little bit into sweep and loft cut. But we're going to do a lot of focus on this part, the detailed drawing, because this is where most of your work goes into. You want to capture absolutely as much of the 3D geometry as you can by thinking carefully about the symmetry of the object. So what's the axis of symmetry, and how do I leverage the power of that to get me the most features for a single operation like a revolve? So equally, we could step back and say, based on this, I just want to do this revolve. And for the region, I want to revolve this feature. So that was one operation that, because of how I had that sketch defined, did exactly the same thing as those three operations in combination. Sometimes you have to do 3, 4, 5, 12 operations to get the features that you're interested in. Sometimes not. But you want to pay attention to how much detail can I get, because this is a pretty convincing water bottle, right? But I want to capture absolutely as much detail as I can in that base sketch. And that's why we're spending so much time on emphasizing the 2D sketch and how to get this to work, to capture some of this fine detail, so that when we go to do an operation, we do a 30-second operation that if you were to try and loft sections and pieces of this, you could get there, but you're going to end up spending a tremendous amount of time doing that process compared to doing what I just suggested. So I want you guys to take on the challenge of finding a couple of things in your environment around you, whether it's a water bottle, whether it's a coffee mug. You may want to empty it first before you start, pouring it all over your keyboard and things. That way you can start recreating some of the things around you. See if you can get it to be dimensionally accurate and get it to have a mass that makes sense under these mass properties. See if it starts to make a little bit of sense. If this were made out of plastic instead, we could leave that and see if this were an Nalgene bottle. That would be effectively, they use not a PET, a polyethylene terephthalate. They use in a lot of cases variations of polypropylene for some things. So sometimes they'll use polyethylene. Polypropylene is pretty common. So we'll use polypropylene copolymer, and that I think has different mass data available. I'm going to reapply that same appearance, even though we've changed the material. So even though we've changed the material, we can have a specified material and a different appearance for the same given part. And now let's take a look at what the mass properties look like. So 206 grams, it's still a relatively thick bit of material, but a couple 100 grams is about right for a vessel of that sort with a high density polymer. So this is part of what we want to do in order to do, again, a sanity check, make sure that we were in the right unit system the whole time, etc. So I want you guys to practice a little bit with some of the things around you, and then let me know what kinds of questions come up as you go to start trying to recreate some of these. Because this next couple of weeks, we're going to start working on a lot of these different drawings. So we're going to work from some drawings to create some various parts. I may go ahead and draw up the example part that I've been waiting to get into, because I need to see if I can get this 3D printed as a single repaired entity, and we'll see what we can do with that. So I'll pause it here and see if there are additional questions.